हरि करना।
So now we will be looking into the most important ML technique or ML method. So which is bootstrap aggregating or bagging. So bootstrap can be used with multivariate data. Bootstrap aggregating or bagging is what we are going to discussing. So what I'm trying to tell is Bootstrap can be used with multivariate data where the rows are sampled as units. Where the rows are sampled as units, a model might then be run on the bootstrapped data, for example, to estimate the stability or variability of a model parameters or to improve the predictive power with classification and regression trees. We can also a best example of regression trees or decision trees. Okay, decision trees. So running multiple trees on the bootstrap samples can then averaging their predictions or with classification taking a majority vote generally performs better than using a single tree. So this process is called bagging, or in short for bootstrap aggregating. So the repeated resampling of the bootstrap is conceptually simple, and Julian Simon, an economist and demographer, has published a compendium of resampling examples, including the bootstrap in his 1969 text Basic Research Methods in Social Science. However, it's also computationally intensive and was not a feasible option before the widespread availability of computing power. The technique gained its name and took off with the publication of several journal articles and a book by Stanford statistician Bradley Efron in the late 1970s and early 1980s. It was particularly popular among researchers who use statistics but are not statisticians, and for use and and for their use with metrics or models where mathematical approximations are not readily available. The sampling distribution of the mean has been well established since 1908. So the sampling distribution of many other metrics has not uh, the bootstrap can be used for sample size determination, experiment with different values for n to see how the sampling distribution is affected. So the bootstrap or aggregating for short is a machine learning technique that uses the bootstrap method to improve the accuracy and stability of statistical models. In short, that's what is bootstrap aggregating or bagging. So especially those that are prone to overfitting, such as decision trees and etc. So the idea behind bagging is to create multiple bootstrap samples from the original data and train a separate model on each bootstrap sample. These models are then combined to make a final prediction. So typically, by averaging their individual predictions for regression problems or taking the majority vote for classification problems. If it is regression problems, it is individual predictions. If it is classification problems, majority vote. So the reason why this works is that each bootstrap sample is slightly different from the others, and the models trained on them may capture different aspects of the underlying relationship between predictors and the response variables. By combining these models, we can reduce the variance of the predictions and improve the accuracy of the overall model. So it can be used for the regression models as well as classification models to basically work on. Okay, So to basically improve to reduce the variance of the predictions and improve the accuracy of the overall model. So bagging can be applied to many types of models. Let me put it here so that it will be damn easy for you. So I call this one is bagging or bootstrap aggregating. So bagging can be applied to many types of models. Most important one is many types of models. Most important one are decision decision trees, decision trees. Then random forest, very helpful, very helpful. Random forests and neural networks. So it's especially useful for models that tend to be unstable or overfit the data, meaning that they perform well on the training data but poorly on new data. So that's what in those cases bagging is very helpful. So by reducing the variance of the predictions, bagging can help to generalize the model to a new data and improve its overall performance. So let's take a simple example to understand bagging very well. So let's take this example. Example is uh, example we will try to improve the performance of a decision tree model. Okay, that's what is the example. Now suppose we have a data set of housing prices. Data set is on housing prices. Okay, housing prices, and so that includes the various features, such as, let me write down the features one by one. Features are: first feature, uh, number of bedrooms. Number of bedrooms, that's the first feature. Then second feature is the size of the lot. The size of the lot. Then third feature is the location. Then after that we have a few more after the location, state, and then price. Yeah, so these are the features of respective data set. Now we want to use a decision tree model to predict. So our problem statement, so let me, yeah, so problem statement, we want to use a decision tree model to predict I'm saying predict the price of a new house based on its features. It's fine. Yep. So based on its features. So however, decision trees can be sensitive to small changes in the data and tend to overfit the training data. So meaning they fit the training data too closely and perform poorly on new data. To improve the performance of the decision tree, we can use bagging in this case. Okay, let me explain what is overfitting, because many people have confusion about this also. So overfitting means they fit the training data. They fit the training data too closely. Too closely means what? For example, if it has a curvature, it will take up exact curvature of the data, like this. Exactly, it fit into that. That's called overfitting. It overly fits into the data. Even the smallest change in the data is also captured. One way you feel okay, it's properly fitting. Now what's wrong in that? Wrong. While training there is no issue, but when you call up for the new data, then the problem comes. What it will do? What it will do? It will perform very poorly. If not very poorly, you can take just poorly on new data. This is what we call it as a overfitting. So now to improve the performance of the decision tree, we can use bagging. So for that, so let's use bagging to improve the performance of decision tree. Now let's create multiple bootstrap samples from the original data. That's the step one. Let's create multiple bootstrap samples from the original data and train. This is the step one. And then once that is done, train a separate decision tree model on each sample. So each decision tree will have different splits and rules, but when combined they will provide a more robust and a stable model. So to make a prediction for a new house, we apply each of the decision tree to the new data and average their predictions, obtain and a final prediction. Let me put this step 3. So to make a prediction for a new house, we apply each of the decision trees to the new data and average their predictions to obtain final prediction. Simple. So this ensemble of decision trees are bagged model. This is what we call it as a bagged model. So this model, after ensembling, so this ensemble of decision trees are bagged model. So it will have reduced variance and better performance than a single decision tree model. So bagging can be further improved by using random subsets of the features for each decision tree. This is known as random forests and can provide even better performance and generalization to new data. Okay, that's another topic. We will discuss it later. That's a random trees. So random forest, that's a different one. So for now, for this example, for the decision trees, we used bagging or bootstrap aggregating to basically improve the performance of our model. First step, we have created a multiple bootstrap samples from the original data. So once that is done, then we have trained separate decision tree model on each sample. I'm saying that's what. So now you will have, if you have created 1,000 bootstrap samples, then you will have 1,000 decision trees models. Then the second step is train a separate decision tree model on each sample. Once that is done, now it's time to make a prediction for a new house. We apply each of the decision tree to the new data and average their predictions to obtain a final prediction. With this, we will reduce the variability and improve the accuracy and improve the performance of the decision tree model. You can do the same thing using the random forest if you do that sampling randomly. That's why I've told you sampling is very, very important for a data scientist. Very important for a data scientist. Very important. So, this type of modeling, this type of model which has used or leveraged the uh, bagging technique is known as the bagged model. So, this is what is bagging or bootstrap aggregating.